Ahoy, Glenwood Springs, it be Cartbeard, the mathematician pirates, here to navigate you through these rough online waters. This yar, more than any other yar, has been especially important that we stick together as a crew. Means any proceeds, any profits, as of right now there are zero. But any financial gain made by this YouTube channel will be split amongst our class. The plunder will be many, the booty will be shared amongst us evenly. And this is my solemn promise to my crew as we go through this rough time together. And you have to bear witness to all these horrible YouTube videos and learn math at the same time. We will be in this together. Thank you very much. And now to return home so I can prepare for math class.
What is up, Glenwood Middle School? Welcome to day 15 of another wonderful week of math class. Congratulations, you made it this far, and today might be a little bit of a review. So we're going to be talking about some statistical terms. We're going to go over what the domain and the range is for a set of numbers, along with the mean, median, and mode. So if all of that stuff feels like super review, feel free to skip a little bit towards the end of the video. So if we have a series of numbers, we have two things that can be defined by those numbers, right? Our domain is going to be all of the x values we can fit. So the domain is the x values. Any x value that is possible is going to be the domain. So for instance, let's say that I am rolling a ball down the hill, right? The domain would be the time, the range would be the distance the ball rolled. So in this case, the domain would be all positive numbers because you can't have negative time. That's not real. Negative time does not exist. So the domain is all of the possible x values that are possible in your equation. The range, then, on the other hand, is all the possible y values that can occur. So, for instance, if I'm asking you how much does a gallon of gas cost, right? The domain would be your gallons, and that would have to be all positive numbers. And the y values, your range, would also have to be all positive numbers because nobody's going to pay you money to buy gas, right? You're going to always have to be paying them money, so it's always going to be positive values. So, for instance, in a normal linear equation, like y equals 2x, our domain would be all x possible values, which would be negative infinity to positive infinity. And our range, in this case, would be the same. Negative infinity to positive infinity. Right? It gets a little bit different. Let's say we put the x value on the bottom of a fraction. So what can x not equal in this case, right? X cannot equal 0, right? So you would go negative infinity to 0, right? And 0 to positive infinity. We will get into what those brackets should look like a little bit later, but if you include something, it should be a square bracket, right? So this means the number is included, and that the circular parentheses means that it is not included, but we'll talk more about that later. Moving on from domain and range, we have the mean, median, and mode. The mean is just your average. So you take how many numbers there are, you add them all together, and you divide by how many numbers there are. The median is going to be the middle number. So if we have a set of numbers like 0, 1, 2, 4, 4. The middle number would be the 2, right? If there are an even set of numbers, right, you have 4 numbers instead of 5, you would take the average, right? So like if we had 0, 1, 2, 3, the median would be between 1 and 2, so the median in this case would be 1.5. The mode is just the most common number. So in this case, we have 2 zeros, so 0 would be our mode. Once again, the mode is the most common number, the median is the middle number, and the mean is the average. Reviewing our domain and range, our domain is our x value. You can remember this because domain is earlier in the alphabet, and so is the letter x. Range is later in the alphabet, and so is the letter y. And once again, those are all possible values for x and y. Now, determining whether something is discrete or continuous is our big challenge for today, and it's not as hard as you might think. So, let's give you some concepts, and you can tell me whether they are discrete or continuous. So, let's start with money. Money is continuous. You can go all the way into fractions and fractions of pennies, and that is relevant in a bank account. So if you're dealing with money, that's most likely going to be a continuous problem. What about if you're dealing with babies? That is most likely going to be a discrete problem because you cannot split a baby in half without being horrible, horrible, horrible human being, right? So if you're dealing with number of babies, right, that would be a discrete because you could only have 1 or 2 babies. You can't have 1.5 of a baby. Let's pick another one. Let's say we are measuring speed. Speed would be continuous, right? You can get all the way down to nanoseconds in time, and you can get all the way down to nanometers, right? Or all the way up to gigameters. I don't even know if that's a thing, but yeah. So any kind of measurement, right, would be a continuous, but any kind of thing would be a discrete. So books, continuous or discrete? Discrete, right? You can't have half of a book. Drugs in your system to fight a bacterial infection, continuous or discrete? So the level of drug in your body. That would be continuous, right? You can have a decreasing level of aspirin in your body that goes down over time, but it can always be measured, right? So you can pick anywhere on the X graph. Other examples, I think we get the point. So discrete versus continuous. Next thing we want to talk about is the rate of change, which is just going to be your Y value over your X value. So you can always find the rate of change. This is also called the unit rate, which is how much does one thing cost. So this is also representative of the slope, and that brings us to the end of our conversation for today. So please return to the live classroom and have a great rest of your day.